Solving quadratics by taking square roots. So just so that we're clear, quadratic equations are any equations that have like an x squared with it. So all of these problems are going to have an x to the second power. So that's what a quadratic equation is. Okay, so this first method we're going to be doing is called taking square roots. And you can really only use this method when it's written somewhat in this form. And we'll get to that later. We'll get to that later. But let's get it started here. It says solve the following equations for x. Okay, so I have x squared minus 25 equals 0. So to solve this, I would solve it kind of like any other equation. What I'm going to do first, I'm going to add 25 to both sides. Maybe I'll show that. I'll do plus 25. So I have x to the second power equals 25. And then before I finish this problem up, I want to, discuss this a little bit. So it says x to the power equals 25. So you did this actually probably a little bit last year as well in your pre-algebra course. With this problem here, there's two answers. It's basically saying what number to the second power equals 25. Well, the answer is 5, right? 5 times 5 is 25, but also negative 5. Negative 5 to the second power is 25. Now, to kind of show work, when you solve this, the inverse operation, we would take the square root to get x. And the square root of 25 is 5. But you have to remember, it's not only 5. It's 5 and negative 5. Those are two answers. Now, let me erase that really fast. You generally write it as a plus or minus 5. That's what that symbol means. It means x could be positive 5 or negative 5. So that's the way generally like to write it. So on B, if I'm solving for x, I would go minus 5. So I have x squared equals 9. And we're at the same sort of thing here. You should recognize that the two answers, what x could be 3 or negative 3, because 3 to the second power is 9 and negative 3 to the second power is 9. So the answer is plus or minus 3. Now, if you're kind of showing full work, the inverse operation of squaring would be taking the square root. So I would say x equals plus or minus 3. In other words, positive or negative 3. So on C, add 1 to both sides. I'm not going to show that work fully. It would be 72. Divide by 2 because we have that coefficient of 2 in front. So we divide by 2 on both sides. I'm going to get x squared equals 36. Take the square root. And I get x would equal positive or negative 6. Okay? So on D, D's going to be a little different. Watch this. I'm going to add 30. Whoops. So I'm going to have 2x to the second equals 150. Then I'll divide by 2. So now I have x squared equals 75. But the square root of 75 is not a whole number, right? So I'm going to take the square root. Now, if you type that in the calculator, you're going to get an irrational number. So now this goes back to the beginning of the year when we simplified square root radicals. So I'm going to say x equals plus or minus the square root of 75. Now, the square root of 75, I'm going to show some side work over here. Square root of 75 can break down into 25 and 3. Square root of 25 is 5, so 5 root 3. So the simplified would be x equals plus or minus 5 root 3. E. Add 12 to both sides. I get x to the second power equals 12. Then I have nothing to divide by. There's no coefficient on the x squared, so now I can take the square root. And again, the square root of 12 is not a rational number. So we're going to simplify this. So for right now, I'm just going to write plus or minus root 12. Now off to the side, I'm going to simplify root 12. So root 12 can break up into root 4, root 3, because 4 times 3 is 12. And the square root of 4 is 2. So I'm going to say this is x is plus or minus 2 root 3. If you need a refresher on that simplifying square roots, go back to the beginning of the year. I don't remember what lesson it's from, but go back. F. Subtract 48 from both sides. So I have negative 3x squared equals negative 48. Divide by negative 3. I'll get x squared equals 16. Take the square root, and 16 is a perfect square. 16 is a perfect square. So the square root of 16, we're going to go plus or minus 4. Square root of 16 is 4. Of course, you'll have the positive 4 and the negative 4. So sometimes you'll have ones that are radicals that you need to simplify, and a lot of times you won't. I'm going to let you do all the rest of those there. Hopefully those examples were good enough. I want to do these bottom two. It says not all quadratic equations will have two solutions. Like all those ones up there are two solutions, right? We have the positive solution and the negative solution. It says sometimes they may only have one solution or none at all. So just let me show you here. So like on this one, when I subtract 7 from both sides, 7 minus 7 is 0. And then you divide by 4, x squared equals 0. And then when you take the square root of 0, there's no such thing as like a positive or a negative 0, right? Like 0 is just 0. It's neither positive nor negative. So you take the square root, it's just 0. You wouldn't put a plus or minus. So just keep that in mind. Sometimes that'll happen. On P is a little unique. So when you divide by 2, we'll have x squared equals negative 25. Well, nothing squared equals negative 25. If it was positive 25, sure. 5 to the second power, 5 times 5 is 25. And negative 5 times negative 5 is positive 25. But nothing squared is negative 25, right? Don't write this, but like 5 to the second power is 5 times 5, which is positive 25. And negative 5 to the second power is negative 5 times another negative 5, which is still positive 25. There's like, even if you type it in your calculator, the square root of negative 25, you're going to get an error. There's nothing squared is a negative number. So this one actually doesn't have solution. This is no solution. Now there's these things called imaginary numbers that you're going to learn in Algebra 2, and we'll call them complex solutions. But there's no solution here. And you might see it read sometime as no real solution. I'm not going to get into all that right now, but there's no solution on this particular problem. Okay. But most of them will, like, so, you know, for the rest of these, I think these are all going to have solutions, so don't worry about it. But just kind of follow these notes up here.